So the big picture for this lesson is exponential growth functions. Exponential growth functions, the outputs are repeatedly multiplied by the same number. And that's if you have integer inputs. So let's look at an example. Probably the simplest example is f of x equals 2 to the x power. So let's do a table of values. So we'll just do 0, 1, 2, 3 to get started. 2 to the 0 power, that makes 1. 2 to the first power equals 2. So put a 2 there. 2 to the second power makes 4. So 4 goes there. 2 to the third power, that's 2 times 2 times 2, and that's 8. So let's see what those do on the graph. 0, 1. 1, 2, 2, 4, 3, 8. And the pattern will continue. You can see these are increasing dramatically at an increasing rate. And what if you have negative inputs? Like, what is the output for an input of -1? Well, 2 to the -1, that's the same thing as 1/2 because you're doing a reciprocal. So that would go right there. And then for -2, that would be 1/4 because it would be 2 to the -2, which is 1 over 2 squared, which is 1/4. For -3, that would be 2 to the -3, which is 1 over 2 to the third, which is 1 over 8. So that is getting even smaller. So the further you go here, the closer these values get to 0, but they never hit 0. So that's called an asymptote. So if you look at the function pattern from left to right, it is increasing at an increasing rate. Especially when you go past 0, you can really see what's happening. You're multiplying by 2 each time you move 1 to the right. So that's exponential growth. So one thing you're going to have to do is evaluate the functions. I just showed you some of that. By making this function table right here and then making this graph. And you're also going to have to identify linear versus exponential growth. Remember, linear is a constant rate of increase, and exponential increases at an increasing rate. So that's the big picture for this lesson.